So after many courses, now you're going to get into some projects, but don't know where to start, right? In today's video, we are going to make a real-time classification project using the MBA dataset from Kaggle. This video will be a beginner project and it will give you guidance on how to work with these real-time projects and how can you get started in the learning of this machine learning project. Okay, so without further ado, let's get into it. Okay, so welcome to the tutorial section of this video. So now what are we going to do is head into Kaggle and make a new notebook in Kaggle. What I mean by that is once you are in kaggle.com, just press this plus icon and then you can see here new notebook. You just have to click that and that will create a notebook like this. So why this and not why not Google Colab or why not VS Code? First of all, Kaggle provides similar kind of hardware just like Google Colab. The one thing that is better than Google Colab is that all of the Kaggle datasets you can access it. Yes. If you create a notebook in Kaggle, you don't have to download anything. You can just access the dataset from Kaggle, use it in Kaggle and use it in this notebook. And that's it. Okay, so I hope you have got my point. Why did I create a notebook in Kaggle? So yeah, let's get into it. First of all, as you can see here, you can see a cell just like Jupyter Notebook. This is a Jupyter Notebook, but the interface is kind of different because it's being Kaggle, right? Okay, so first of all, what we need to do is run the cell that will connect a runtime to our notebook, plus it will connect an OS path to Kaggle input datasets. So you can now take inputs from the Kaggle websites. Okay. So now I hope you have got my point. Now what we will do is we will just import. We will do our necessary stuff like import the libraries, then import the framework, etc. Import the models, then matrix, accuracy matrix, etc. And then do our EDA and then train our model. So yeah, let's get into it. First of all, what we will do is we will import the necessary libraries. Of course, we need pandas, so we will import pandas. Okay, as PD. Then what we will do is import numpy as np. I'll just move it. Okay, just normal things, right? Now we will import matplotlib dot pyplot as plt. Okay, so now that is done. We also need Seaborn for confusion matrix. Obviously, this is an end-to-end classification project. Although we will not be deploying this onto some kind of deploying website or anything like that, or AWS, something like that. But if you want to do that, I have done this in the one of my past videos. What you can do is head down to that video. That video's name is like service chatbot, end-to-end service chatbot project using machine learning. So what I did there is made a Flask serverless API and then we just deployed it on Core. By the way, Core is free. So if you want to do that kind of thing, then upload your project into the cloud or any type of service. You can just do that by watching that video. No worries, nothing will happen. Okay, so yeah, so let's head into this end-to-end classification. So for now, we need Seaborn for confusion matrix, as I said. So import Seaborn as SNS. Okay, now we will import random forest classifier in order to classify for our MBA dataset. Okay, so by random forest classifier, it's an Ansible model that combines advantage of a whole lot of models into one. It is based on decision tree. So yeah, it is better than one decision tree. That's it. Okay, so we will import from scikit-learn dot ensemble. I hope I spelled it correctly. Yep. Here. Okay, scikit-learn ensemble. We will import, what do I say, random forest classifier. Okay, so now that's done. You can import any other classification models like SVM or even neural network, and just train this on the neural network, and let's see what happens. Okay, so now what we will now import is some pre-processing things like label encoder, then min-max scaler, etc., etc. Then to split our data, we'll import the train test split, and we'll just import that. Okay, so import, sorry, again from scikit-learn dot pre-processing this time. We will import min-max scaler. Also, we will import label encoder, not binarizer. We'll import the encoder, and as you can see, the auto-completion of Kaggle's notebook is far better than Colab. Yeah, it is not like delayed or any kind of that. So now let's import scikit-learn dot model selection. We will import the train test split. Sorry, the T is not capital. Test split. Okay. Then we will import the classification report. So from scikit-learn dot model selection. Sorry, it's in metrics. We will import classification report. Okay. And from again model selection, we will import some more things like cross-val score. Okay. Okay, that's it. And if I run this, yep, that runs fine. And now what we will do is just start working on our project. The first step, we will import the dataset. So let's say this is df, so df is equal to pd dot read CSV. Okay, and that's okay. I think I have a name ready, I mean a string ready for just this. If I go here, MB, okay, that should run fine. And if I say df, okay, that's gonna have an input, and then what we will do is MBA admission dataset. Okay, the first thing that you notice here is if we do, what do you say, MBA dot CSV, it should not be set to all, and I don't know how I can just cancel it. I don't know. It's not about this. Okay. Nope. Nope. I don't know why, but that happens for some time. I don't know. So if I go to datasets, and cancel this for now, and let's say MBA, and yeah, that's the MBA admission dataset. And no, this is not the dataset that I was looking for. If we again search, yep, that's the one. Yep, that's the one. So now, instead of downloading, if we go to here and just say new notebook, that should again do it. We'll just create while keeping this MBA admission dataset as it is. So now you know how to create a notebook. Seems like the searching method doesn't work that much well. That's it. That's no worries. Okay. So we'll just say MBA admission classification. Yep. And now, if we again run the cell, and this time, instead of doing things normally, okay, what we'll do now is where are my notebooks? I think that's it. Yep. I'll just copy this, Control A, Control C. And if I do Control V here and run this, that should run fine. So what I will do is df is equal to pd dot read csv, and what we will read, the string that was already here. Okay, so if I go to this string, copy this, Control C, and then again do a Control V here, and this time if we run, it will run fine. Yep. Okay, so that's how you do it. And if I just check the df, yeah, you should have it right here. So as you can see, we have application IDs, then genders, then GPAs, images, etc. etc. Okay. Now, what we will do is we will just gather some information from the dataset. So for the info, the first thing that I do is .inf. That will give us the number of columns, number of rows, and how many non-null values are there, and every data of the column. Okay, as I see, there's one boolean and 3 floats, 1 integer, and 5 objects. Quite a versatile data that we have here. Now, first of all, let's do some data pre-processing. Let's check what we need to do. So if you see the admission, the object type is there for admission column. Okay, and there are only 1000 values. I hope those where's the admission? Yep. So for the admitted student, it says admit, but for another remaining student, it is not a number. So it's a non value. So let's just fill it up with the reject value. So df of admission will be equal to df df dot admission. We will do this in okay like that, and then fill in it. What we will fill it with? The reject value. And now let's just replace the man value with infinity or minus infinity. Sorry, let's replace the infinity or minus infinity values with man. Okay. So what we will do is df dot replace, and we will do np dot inf, comma np dot minus inf, and now we'll fill it with np dot man, and I hope if we do in place equal to true, that should work. If I run this, nope, it's not df. Okay, then dot nope, the minus is here, not the yeah, that should run fine. If I check df again, yeah, all the values are filled. Okay, no need to check df then. Okay, now let's encode the target. So we will just label admission column using the encoding strategy. So we will do label encoder equals to, remember we have imported label encoder, we'll do label encoder, and what we will do, we'll just initialize it and do df of admission equals to label encoder dot fit transform. Okay, and what it will transform, the again that admission column, admission. Okay, so if you run this, it should run fine. Now for every index in the enumerate of label encoder and classes, what we will do is print the index as x, okay, and clx. I guess I didn't do clx here, and it will give us 0 for admit, 1 for reject, and 2 for against. Right? That's the label encoding that has been done. Okay. Now, what we will do is we will just do some initial EDA using like describe methods and then doing some visualization using matplotlib. So what we will do is df.describe to get data of the numerical columns. As you can see, the counts, the mean, the standard deviation, etc., etc. That sounds good to me, although mean is far off for the application ID. Although we don't need application ID, we will just move it in the future. We don't need to worry. Okay, we will do some visualization. So plt.figure. Let's do fix size equals to 6,4. That should wait. And what we will do is do a count. So first from C1 we will do count plot. We will do x equals to gender, and data will be from df. Then let's give it a title. So plt.title. What title are we going to give? Obviously gender distribution. I hope I spelled it correctly. So then now let's give the x and y axis some labels. So for x we will give gender, and for y it will show us the count. So plt.xLabel, what's it? That's gender. Okay, and same with the y label. Here we will do the count, and here we will say y label. That should do it, and let's just do plt.show and call the function, and it should show us the graph. As you can see, the count of male students is higher than female students, although we don't want to make a model biased to one gender, so we'll be just removing this if we do. But yeah, for now you can just take it as female students are like much more lower count than the male students, and that's a problem. Yeah. Let's do some GPA distribution. Again, I just copy this. If I paste this here and just do list plot, this time we have to do a list plot, by the way. Okay, and for the data, what we will do is df of GPA, and let's just set the KDE to true, and let's just do 20 bins. So let's do 20. Okay, so the title will be GPA distribution, here it will be GPA, and here it will be frequency. Okay, and if I show this, the closing parameter should be right there, and yep, as you can see, the GPA distribution is like a bell curve. So that's like one of the most one of the best distribution that you can get. Yeah. So now let's do a distribution for GMAT score. I think there was a column called GMAT. So yeah, let's do a distribution for GMAT score. So again, we'll do a his plot, and let's just keep this right here. Let's do GMAT distribution and GPA, GMAT score, and again frequency. And if I just do this, yep, that's again a bell curve. So yeah, that's a good one. Or no, no. That's what I thought. I didn't change it. Yep, the GMAT distribution is not a bell curve, although it is a good one. So yeah. Oh, but yeah, as you can see, that's what is this? 400, 200? No, I don't know. That's a problem that can generate some outliers. So yeah, let's just plot some admission statuses. So what if we do again Control V, and this time again we will do count plot. And what we'll do is admission, and let's just pass it the data as df. So status distribution, x label will be status and y label will be count. And if we do this, okay, this count and plot, what happened? Oh, it is x equals to, and we have to remove this df. Yeah, okay, my god. So as you can see, if we go up here, they have rejected many. Okay, they have rejected many students, and some are on the waiting list, and some are around 1,000 are accepted. Although it is 1,000, I guess. If we go up here and check, yep, it is 1,000. 1,000 of the students are accepted, and yeah, that should be quite a bit. PLT, let's do a correlation matrix this time. So let's figure out. Again, do a fixed size equals to, again, this time let's do 10 by 10. No, let's do 8 by 6. 10 by 10 will be a larger one. So SNS dot heatmap. What we will pass it, the df column, and in it, what we will pass the GPA. Then let's do GMAT. Let's do whatever the other columns. Okay, the work experience, admission. Okay, and there's also an international column. Okay, so we will do international admission. That should do it. Let's also do work experience, EXP. And do admission. And before admission, let's do international. And just give a column. Okay, so now let's give a title. So plt.title. This time what we will do is the correlation, and then let's do plt.show. That should do it. And it should take a moment. Okay, what happened? What happened? Okay, fine. There's a quite a bit. Okay, .cod. That's what I forgot. Okay, you know what? I have to pass some more parameters. And I forgot many things as I remember. Yep. I have to do this and this, and I will do a not equals to true, then cmap equals to cool warm, then what we will do is just let's do fmt. Oh no, let's do fmt equals, how many decimal points do we want? Let's do 2 decimal points, and that should show us the map. What happened? Okay, fine. To say map, cool world. There's nothing called cool world. It's cold warm. That's something. Okay. So now if we check the correlation matrix, yep, it's okay. The GMAT score quite a lot does, and also the GPA. Okay, so those are the two things we have to worry about. And yeah, let's drop on let's stop the column. So df.drop. Now what we will do? We'll do columns equal to race. Obviously, we don't have to be biased. And then let's do application ID because it is irrelevant. And let's again do gender because again biasing, measures, biasing, then work industry, again it is kind of biasing, not much, but yeah, work industry, and also work experience, EXP. Okay, so this is the df.drop, and what we have to do is df is equal to, and that should do it. Yep. And let's now scale these values, remaining values. Let's first check the df. Yeah, it consists of the admission, GPA, and international values. Okay, done. Okay, so let's do scalar equals to min max scalar. Let's initialize it, and let's do continuous features equals to GPA and GMAT. Those are the continuous things. And let's do continuous features will be equal to scalar. Let's fit our scalar to that, scalar.fit transform. And what we will pass again the df of continuous features. And that should do it. If we run this and again check df, yep, that is now scaled properly. Okay. So now let's get the admission count. So add count equal to df of admission column, and now let's just do value counts. Okay, so if we do add count, it should give us, yep, exactly that. Now if we do df.info, sounds pretty good and looks pretty good. Yep. Now let's make some training and testing data. Okay, so let's do test data equals to df of df's column, admission column, that's equal to 0. Let's just do test data 1, or let's say 0. Okay, where this is 0 and dot sample. Let's sample the 20 pieces and then with the random state equals 42. And if I just copy this down, and this time we will just do 1, and this time we will just do 2, and here also we'll do 1 and we will do 2. Okay, now let's combine all the data using the pd.concat. So pd.concat equals to, not equals to, pd.concat, and what we will do is pass the test data 0, also the test data 1, and the test data 2 in order to concat it now, and we will just save it into test data. Okay, so that's the whole test data. Then train data will be equals to df.drop, and what we will do, test data dot index. So we'll just drop the test index from that, and let's just take the test data, let's just see the test data dot shape, and train data dot shape. If you run this, yep, sounds pretty good. Okay, so once the test data and train data is sorted, what we will do is resample the data. So for resampling the data, we have this downsampling rejecting the downsampling the reject class. Okay, so what we will do is pull down the number of rejected applications and just match it with the accepted applications. Okay, so this should run fine, and now that's all 1000, although you can all copy this data, that is nothing much. Okay, so now let's just do the model training. So now what we will do is x train equals to sampled data, because this is sample df. Okay, so sample df dot drop, and now from this we will drop the admission column, and we will do access equals 1. And now let's do y train equals sampled df dot sample df's admission column, so admission column. Okay, that's fine. Now we will do x test equals to test data dot drop, and again we will drop the admission column, and we will do access equals 1, and let's do y test equals to test data's admission column. So test data's admission column. Okay, that should be okay. Now what we'll do is train our model. Okay, so let's define the model and train it. Okay, so rf model will be equals to random forest classifier, and what we will do is do random state equals 42 to reproduce the results. Okay, now we will pass our data to that model. So model dot fit, and what we will fit to the model, let's do x train, y train, Okay, it is RF model. Okay, it has been fit. So now let's just do rf dot predict. Okay, I guess yep. First of all, let's just do predict function, and what we will predict, the X test, that's RF model. Yeah, as you can see, that's it. And yeah, let's check the score of our model. If we do RF model dot score and do X test, Y test, and that should give us, yep, that's a pretty low percentage by the way, but still it's a good one. Why? Because we don't have that much column to predict on, because we just drop down the categorical like for now. Let's just take a look at the classification report, because we have just imported it, right? So let's just do classification. Okay, here, classification report, and what we will pass, the Y test, and then we will pass the RF models dot predict, and what it will predict, the X test. Okay, and if we're in this, okay, then next this one. Okay, yeah, about that, it just doesn't like show in a good one, but yeah, that should be it. Is there any way to display this? I don't know. If I do print, yeah, that does it. So yeah, as you can see, the precision score, the record is pretty good for 0 and 1, although for 2 not so much. So 2 is the one that held us down in this current situation. Okay, so yeah, that's it for this tutorial, and I hope you have enjoyed it, and I hope you do your research and do your projects on with your own now from now on. Yeah, and also the MBA admission classification notebook name was taken, so yeah, we'll just update it with the notebook, and yeah, that should go. And that's it. That's how you apply your currently accumulated machine learning knowledge into a real-time project. So I hope you guys have enjoyed. If you did, please hit that like button and subscribe to Analytics for more such videos. I'll be making sure that you are satisfied with all the projects that I make in the future. This is Atharva from Analytics, and I'll see you in the next one. Bye-bye.